and welcome to our Mathematical Thinking final project. Today we will be talking about the edge picking algorithm, also known as the global greedy algorithm. This is a type of greedy algorithm that is used to find a Hamiltonian circuit in a graph, which we'll explain more on the next slide. Before we dive into how the algorithm works, let's quickly go over the rules of a Hamiltonian circuit so everything makes sense. First step, you must visit every vertex exactly once. You cannot repeat. Step 2, you must return to your starting point to complete the whole circuit. Step 3, you cannot create a smaller loop before visiting all of the verticals. Step 4, and no vertex can have more than 2 edges in the final circuit. These rules are important because the algorithm is designed to follow them while choosing the best edges. So what exactly is the edge picking algorithm? In simpler terms, it is a method used to find a Hamiltonian circuit, which is a path through graphs that visit every vertex exactly once and returns to its starting point. The algorithm works in 3 steps. First, we find the edges in the graph with the lowest weight. That's the smallest number that's going to be on the diagram. Then, we pick the next smallest edge that doesn't form a closed circuit too early or create a vertex with 3 edges, because that would break the rules of the Hamiltonian circuit. Step 3, we repeat this process until we can finally connect back to the starting point with the last edge completing the full loop. In this example graph, you can see all the weights between the different points labeled A through F. Using this algorithm, we would begin by selecting the smallest number, which is 9, and then continue from there, always picking the smallest number so we don't break the rules. When going over the basics of the edge picking algorithm, like we talked about in slide 2, you start at the lowest weight. Then the next step, choose your lowest weight and begin working your way around the edges. So therefore, in this example, you would go from 1 to 5. Once you have completed the circuit using the edges with the lowest weight, make sure that you add to get your final and total weight.
For example 1, we're going to use the edge picking algorithm to solve the problem. The goal is to connect all the points using the smallest possible total edge weights without forming any circles too early. First, we look at all the edge weights and start choosing the smallest ones one by one. We start with the edge between 3 and 4, which it has a weight of 5. Then we pick 5 to 4, which is 6. After that, we choose 1 to 2 with a weight of 8. Next, we include the edge from 5 to 1, which is 17. Finally, we include 2 to 5, which gives us a complete connection of all the points. At this point, all the vertices 1, 2, 3, 4, and 5 are connected. We add up all the edges weights we used. 5 plus 6 plus 8 plus 17 plus 12. That gives us the total of 48. For example 2, we're solving it using the edge picking algorithm. That means we need to connect all the vertices A, B, C, D, and E using the smallest total weight possible without creating any loops. First, we list all the edges in order from smallest to the largest. The smallest edge is between B and E with a weight of 21, so we pick that first. Next is the edge between D and E, which has the weight of 26, and we add that because it connects the new point. After that, we choose the edge between A and E, which has a weight of 29. Then we pick the edge between E and C, which is 34, and that connects the final point. At this point, all 5 vertices, A, B, C, D, and E, are connected, and we haven't formed any loops, so we're going to stop there. Now, we add up all the weights of the edges we use: 21 from B to E, 26 from D to E, 29 from A to E, and 34 from C to E. The total weight is 110.
On the behalf of me and my group, we hope you learned and enjoyed the presentation. Thank you for your time.